There was a time when you could turn on a computer, start typing code, and immediately see something happen on the screen. No setup, no configuration, just you and your code. That feeling of immediacy is something I think we've mostly lost. Today, even when you're building something small, there's often a lot of friction before you ever see a result. You're setting up projects, learning framework structure, and understanding tooling before you've written a single meaningful line of code. And don't get me wrong, those tools are powerful, but that power often comes from layers of abstraction that make it harder to see what's actually happening. This feels especially relevant right now with AI tools. AI can generate a lot of code very quickly, and you can get impressive results fast. But if that code is operating inside systems you don't understand, you lose control over how and why things work. What I care about is having a fast feedback loop and a clear mental model where you can write code, see the results immediately, and understand what's going on under the hood. That kind of clarity lets experienced developers move faster and makes AI-generated code easier to understand. So when it makes some mistakes, you can spot it and fix it. I wanted to bring back that fast feedback loop, but in a modern environment, using JavaScript. That's what Pi.js is. Pi.js is a lightweight JavaScript library for building small retro-style games and visual demos. It's designed to stay out of your way, give you explicit control and scale from quick experiments to more serious projects. Let's take a look at this code. You can look at this and immediately understand what's going to happen, even if you've never used Pi.js before. There's no hidden structure deciding what gets drawn or how things are managed. You're just issuing draw commands, and they render exactly where you tell them to. This isn't a debug console or a side panel, this is the output. Even though this looks simple, it's not limited. Under the hood, Pi.js is doing real rendering work, handling resolution, scaling, and performance, but it stays out of your way. What matters to me is that the mental model stays small. If you want to change something, you change the code that directly controls it. This kind of structure works really well with AI. When AI-generated code looks like this, you can read it and understand it, and correct it when something goes wrong. One of the things that you do when you start up a Pi.js project is to define a fixed screen resolution. In this case, I'm using a 320 by 200 resolution, the kind you'd see in older games. That might sound old-fashioned, but it simplifies everything. When you work at a fixed resolution, you're always reasoning in the same coordinate space. You don't have to think about responsive layouts, device pixel ratios, or how big the window happens to be. Pi.js takes care of scaling that resolution to whatever screen you're on. You're still writing your code as if you're working on a simple, predictable canvas. When something appears at position 3030, it's always at position 3030. There's no guessing how the system is transforming things behind the scenes. Once you have that foundation, everything else in Pi.js builds on top of it. At its core, Pi.js is about drawing retro-style graphics. You get pixel-perfect rendering, simple primitives like lines, rectangles, circles, and text, and a predictable coordinate system that never shifts under your feet. You can also draw images and sprites, still using the same explicit coordinate system. Whether you're drawing a UI, a tile map, or a character sprite, you always know exactly where things are going to land. What you draw is what appears on the screen. Input in Pi.js is explicit and flexible. You can handle input as events or as immediate pulled state. Sometimes you want to react when something happens. Other times you want to ask, is this input active right now? Pi.js supports both. Your code decides which approach makes sense. Sound follows this same philosophy. You load sounds, you play them, and you control exactly when they trigger. There's no complex audio system you have to manage just to play a sound. If something happens and you want audio feedback, you call it. Graphics input and sound are simple building blocks. Pi.js doesn't force an architecture on you. Because the API stays small and predictable, the code stays readable, even when it's generated with help from AI. So that's what Pi.js is. Let's talk about what Pi.js isn't. Pi.js is not a full game engine. It doesn't come with a built-in physics system. It doesn't impose an entity or object model. It doesn't decide how things should interact. That's intentional. A lot of what makes a traditional game engine complete is glue code, systems that lock you into a specific way of structuring your game. Pi.js leaves that out on purpose. Instead of forcing an architecture on you, it gives you a clean, predictable foundation and lets you decide how things fit together. You choose how objects interact. You choose how state is updated. You choose what kind of physics makes sense, or whether you want physics at all. That level of control makes Pi.js a good fit for people who care about how their code is structured. It also makes the code easier to reason about and easier to fix when something goes wrong. Pi.js is for people who like working close to the code. It's for learning, experimentation, and for building real projects where clarity and control matter. If you want to try Pi.js yourself, the link is down in the description. Just visit pi.js.org. Thanks for watching.